There are places on Earth no human will ever reach, places so remote, so extreme, that even our best machines can only guess what lies there. And yet, something is moving. Beneath the Pacific Ocean, nearly 1,000 miles underground, far below the ocean floor, deeper than Mount Everest is tall, scientists have detected something shocking. A structure, massive, dense, hidden for eons and completely out of place. It wasn't there in any model. It defied every tectonic rule we thought we understood. It sat where no tectonic plate had ever sunk, no volcanic plume had ever risen, and no scientist had ever dared to look. Until now. We can't drill into Earth's mantle, not because we don't want to, but because we physically can't. The deepest hole humans have ever drilled, Russia's Kola super deep borehole, reached just over 7.6 miles. That's barely scratching the crust. The mantle begins on average about 22 miles down, and it goes way deeper, more than 1,800 miles down. So how do we know what's inside our own planet? The answer lies in earthquakes. Every earthquake sends ripples, called seismic waves, through the Earth. These waves bend, bounce, speed up, or slow down depending on what kind of rock they travel through. And by measuring how they arrive at different seismic stations around the world, scientists can reverse engineer a picture of Earth's insides. It's like giving the planet an ultrasound. Earthquakes create the signal, seismometers record the echo, and from that we build 3D maps of what's underneath. For decades, this technique, called seismic tomography, has helped us identify things like magma chambers, tectonic plates, and even giant blobs near the core. But here's the catch. Traditional tomography only looks at the arrival time of those waves. It gives you a rough image, like an old black and white scan. What came next changed everything. Instead of measuring just when seismic waves arrive, this method captures the entire shape of the wave, how it bends, twists, decays, echoes. It's like going from a stick figure to a high-res MRI. But this method needs power. Massive power. Running a full-scale global simulation would take your average desktop computer hundreds of years. So a team of researchers from Zurich and Caltech turned to one of the world's fastest supercomputers, PIZ-DIENT, located at the Swiss National Supercomputing Center. They fed it over 30 years of earthquake data, 430 major quakes from 1990 to 2022. Data collected from hundreds of stations from every continent. This wasn't guesswork. This was the clearest picture of Earth's interior ever attempted. It was supposed to validate the model, to give us sharper resolution of what we already knew. It did not. At first, the images were subtle, a few strange delays, unusual wave behavior. Then, the patterns grew more consistent. Some seismic waves were bending in ways no one could explain, and they were doing it in places with no geological excuse, no subduction zones, no known faults, no volcanic activity. The most prominent anomaly? A dense structure located beneath the central western Pacific between the Mariana Basin and the Caroline Plate, nearly 1,000 miles underground. It stretched hundreds of miles across. It was flat in shape, horizontal, not vertical like a sinking tectonic plate, and it didn't taper off or twist like a slab of ocean crust. It just sat there, block-like, immovable, silent. The team at ETH Zurich ran the simulations again and again. Different filters, different starting models. No matter what they tried, it wouldn't go away. Eventually, they gave it a name, the Deep Wave Breaker, because that's what it did. It broke waves. Bent them, deflected them, like an invisible wall, hidden inside the planet. According to every model we've ever had, this is impossible. The mantle is supposed to behave in predictable ways. Cold slabs sink during subduction. Hot plumes rise from the core and create volcanoes. The interior is a slow-moving conveyor belt of heat and rock. But this structure? It didn't come from the surface. It wasn't part of any known plate. It wasn't rising from the core, and it wasn't alone. When the researchers expanded their simulations, they found similar anomalies under parts of Central Asia, the Atlantic Ocean, and even beneath ancient continental interiors. But the Pacific structure was the clearest, the largest, and the most disturbing. because it sat nowhere near any tectonic boundary. So what is it? The truth is, no one knows. But the theories are starting to take shape. Theory 1, it's an ancient piece of continental crust, something from 1 billion years ago before modern tectonic plates even existed. Maybe it was subducted before the current plate system took form and somehow stayed intact. Theory 2, it could be a chemically distinct zone, full of heavier minerals like iron. Maybe during Earth's early formation, some dense material sank and settled in this pocket and never mixed with the rest of the mantle. Theory 3, it's the ghost of a dead mantle plume, a hot upwelling that rose from the core, cooled, and solidified in place millions of years ago. None of these ideas are proven. Some scientists aren't even ready to guess. What they agree on is this: the structure is real. It's there, it's dense, and it's disrupting the way waves move through Earth. This isn't just about a single discovery. It's a crack in the foundation of modern Earth science. If a structure this large, this dense, and this anomalous can exist deep beneath the Pacific and remain undetected for decades, then what else is down there? What secrets has the mantle been hiding? More importantly, what if our models have been wrong? Because up until now, our understanding of Earth's interior has been based on assumptions, smooth gradients, predictable convection, logical results. But now, a miles-long unmapped structure says otherwise. In the wake of this discovery, seismic labs around the world are rushing to reanalyze old data using full waveform inversion. What we once dismissed as noise or error might have been signals, and deep Earth modelers are now rewriting the rules. Maybe the mantle isn't just a molten highway of rising heat and sinking plates. Maybe it's a broken ancient battlefield, a place where the ghosts of early Earth still linger, trapped under unimaginable pressure, unmoving for billions of years. Researchers at ETH Zurich and Caltech are now planning new simulations, new chemical models, even synthetic tests to replicate how this anomaly might have formed. But one thing is clear: we are not done learning what's under our feet. For centuries, we've looked to the stars, wondering what's out there. But maybe the real mystery was beneath us all along. Hidden under miles of rock and ocean is something no one expected to find. A structure the size of a lost continent, a wave breaker in the deep, a riddle etched into Earth's very core. And the truth? We're just starting to listen. What do you think the structure could be? Ancient crust? A sunken plume? Something we haven't even imagined yet? Let us know in the comments. And if you want to go deeper into Earth's biggest mysteries, don't forget to like, subscribe, and hit the bell. Because down here, where no one's ever seen, the story is only just beginning.